let's take a look at some of the differential equation homework problems. And when you're dealing with differential equations, these are basically equations where you have a derivative in the problem. And when you're solving equations, usually you get a number as a solution, but for differential equations, your answer is actually an equation. I think it's probably best for me to walk through some examples here and then explain what the final answer means in terms of the original problem, and therefore you might have a better understanding of what a differential equation solution means. Okay, so let's take a look at this first problem here. Just a heads up, when you're doing differential equations, there's quite a bit of algebra to do, so you want to make sure that you're checking all your steps, because as soon as you make one mistake, the entire question is actually wrong. So I will try my very best to limit my mistakes, and just to warn everyone in advance, these questions do take a little bit of time. Okay, so let's take a look at everything here on the left-hand side. I have two terms, and I have a 0 on the right-hand side. What I'm going to do first is I'm going to take this fraction x over y, and I will move that to the other side. So if I do that, I get dy over dx equals to negative x over y. After that, you want to make sure that the y's line up with the y's and the x's line up with the x's. So in order to do that, you can just do a crisscross. So this y in the bottom will go to the left-hand side, and this whole dx term will go on to the right-hand side. So if I do that, I get y times dy equals to negative x times dx. All right, so now I have all the y's on one side and all the x's on the other side. Once you have accomplished that, you want to get rid of the dy's and the dx's, and the only way to get rid of those terms is by integrating each side. So you want to integrate the left-hand side, and you will also want to integrate the right-hand side. And once you integrate, the Superman sign or the S shape will eliminate the dy and the dx. Okay, so ask yourself, what is the antiderivative of y? Well, the antiderivative of y is going to be y to the power 2 divided by 2, and that's it. And therefore the integration sign and the dy symbol are completely gone. After that, what is the antiderivative of negative x squared? Well, that's going to be negative x squared divided by 2 and then a plus c. Okay. After that, you want to solve for plus c, and in order to do that, you need to go back to the original problem and use this condition right here. So y of negative 2 equals to 1. All right, so y of negative 2 equals to 1. All right, so when you're trying to put this into the problem here, what this means is the negative 2 is going to be the x value, and this 1 will be the y value. Okay, so let's let me circle the y variable, and let me circle the x variable, because these numbers are now going to go back into this equation here. So this 1 right here will go and replace the y, and this this is supposed to be y, not 1. And this negative 2 will basically go over here now. Okay, so let's go ahead and insert those numbers in. So this is going to be 1 to the power of 2 divided by 2 equals to negative 2, and then square that, divided by 2, and then plus c. All right, so I need to carefully insert those numbers in. On the left-hand side, 1 squared divided by 2 is going to be 1/2. And then this is going to equal to, well, negative 2 squared is going to be 4. 4 divided by 2 is going to be 2. And that's going to be equal to negative 2 plus c. And then if I bring the negative 2 over, that's going to be 1/2 plus 2 equals to c. And c would equal to 5 over 2. All right, so c equals to 5 over 2. What we're going to do now is we're going to go back a few steps here. And I will just kind of erase this and erase that. And I want to perhaps just continue on with this box right here in red. So let's go ahead and update this equation here, because we just found the value of c. So now I have y squared divided by 2 equals to negative x squared divided by 2. And my c value was 5 over 2, so I can add the plus 5 over 2 right next to it. Okay, so after that, once again, if I go back to the original question, we have to make sure that our equation is in terms of y, so y equals to f of x. So I need to go ahead and solve for y now. What I see next here is there's a 2 on the denominators there, so I can just pretty much cancel all those out. And if I do that, I get y squared now on the left-hand side. And on the left-hand side, I'm just going to rearrange these terms just to kind of clean it up. So now I have 5 minus x squared. And after that, I can take the square root of both sides. And if I do that, I get y equals to plus or minus the square root of 5 minus x squared. Okay, we're almost done here. We're about 90% done here, 90% done. If I go back to the original problem, I know that this condition was given to me, and what this really means is that the x value is -2 and the y value is 1. When I take a look at this graph here, basically it's going to be a circle with the radius of 2.5 from the center. And the positive side is going to be there, and the negative side is going to be on the bottom. So we have this plus or minus sign in front of the radical there, and because the problem has to go through the point -2, 1, now you got to be careful here. Over here, this is going to be half or the square root of 5, and -2, 1 is somewhere over here. That's going to be -2, and this is going to be 1. So what that means is basically we need to get rid of this whole bottom part because the graph actually doesn't go through the point -2, 1. So I can get rid of the bottom piece, and when I update my final equation here, it's just going to be the positive value now. So y equals to positive the square root of 5 minus x, because this graph right here in light blue actually goes through this point of -2, 1, which is right there. So that's -2, and that's about 1. Okay, and that's how you finish off that problem. All right, so this is my answer here, and I won't do this for all the problems, but I want to go back to the original question and further explain what this answer means. Our answer is y equals to the square root of 5 minus x. Okay, so let's go back to here, and let me just erase all this, and let me erase all that. Erase all that. I need to kind of explain what we just found here. Okay, so my answer was y equals to the square root of 5 minus x squared. That was my answer. So I want to just take a few minutes here and explain what does this answer really mean in the context of the original problem here. So on the left-hand side here, and this is the right-hand side, on the left-hand side here I have the derivative. So when I take the derivative of my answer, I should get -x over y. That's what this problem is asking us to do. We need to find a function in the form of y equals to f of x such that when I take its derivative on the left-hand side, I actually get this expression of -x over y. Okay, so let's just do the derivative and let's just see if our answer actually does indeed satisfy this equation here. Okay, so I know y, if I just write this in terms of power now, it's 5 minus x squared to the power of 1/2. And if I take its derivative, that's going to be 1/2 bracket 5 minus x squared to the power of -1/2 times -2x. If I do that, these guys will cancel off, the 2's, and I just get -x over the square root of 5 minus x squared. So that's my derivative. So let me just put that here on the left-hand side. So my derivative is -x over the square root of 5 minus x squared. Okay, and that's the left-hand side. And on the right-hand side, I have this -x over y. Now, as you can see, the -x's match up, right? Those guys match up. Now ask yourself, what does y equal to? Well, y equals to our answer right there, right? So y equals to the square root of 5 minus x squared. So if I erase this, this is the square root of 5 minus x squared. And as you can see now, the left-hand side equals to the right-hand side. And that's what's happening when you're solving differential equations. Okay, so I can't do this with all the examples where I check my work. For the next example, for the rest of the examples in this video guide, I will just do the algebra work, but it's very important to understand like what your answer means. You need to take it back to the original problem, take its derivative, and make sure that the left-hand side equals to the right-hand side. And that's how differential equations work. Okay, let's move on to the next problem. Okay, so for my next problem, I have the derivative of y equals to 2xy squared, and my initial condition here, or my condition for this problem, is that f of 2 equals to -1. So if you want to just translate this into a coordinate, that's going to be 2 comma -1, where this is your x value and that's your y value. Okay, so let's go ahead and solve this differential equation. Step number 1, you want to make sure that the y's and the x's are on the same side of the equation. So let's go ahead and put an equal sign here. I see this y squared here, and that's on the right-hand side, so let me move that to the left-hand side. If I do that, I get y squared, or sorry, not y squared, y prime divided by y squared equals to 2x. Okay, so from there I can see that the y's are on the left-hand side and the x variable is on the right-hand side. So that's step number 1. Make sure that the same variables are on the same side of the equation. Okay, so after that I'm going to rewrite this as y to the power of -2 times by y prime equals to 2x. Now if I want to get rid of y prime, I need to take the antiderivative of both sides. So here is my antiderivative, and here's my antiderivative over here. Okay, so let's go ahead and find the antiderivative of my problem now. So the antiderivative of y to the power of -2 is going to be y to the power of -1 divided by -1. And if I have to simplify that, that's going to be -1 over y. So let me just rearrange this by erasing that. And this will be -1 over y equals to, and then what is the antiderivative of 2x? Well, that's going to be 2x squared divided by 2 plus c. Okay, and now we need to solve for c here, and I know based on the original problem I had f of 2 equals to -1, and I already mentioned that this was the x value and this is the y value. So basically this 2 is now going to replace the x, and this -1 will replace the y. Alright, so let's go ahead and insert those numbers into the equation so I can now solve for the c. So this is -1 over -1 equals to 2 bracket squared divided by 2 plus c, and I will go ahead and plug in the 2 there, and I forgot the c there. And let's go ahead and simplify this now. This is going to be 1 on the left-hand side, and on the right-hand side, the 2's can cancel, and 2 squared is going to be 4. So that's going to be 4 plus c. And if I go ahead and solve for c by bringing the 4 to the other side, 1 minus 4 is going to be -3. So my c value is -3. Okay, let's go back to this middle step here. Let me just erase all this. So let's go back to this part of the equation right here, and let's go ahead and just update that because I found my value of c. So my value of c is -3. So if I go ahead and plug everything back in here, let me just cancel off the 2's now. That's going to be now x squared, and then -3. Okay, so we found our value of c, and remember I have to make sure that my solution is written in the form of y equals to something. So let's go ahead and solve for this. basically I can, there's several ways you can kind of look at this. Let me just highlight these two pieces right here. I can just swap those two pieces. If I do that, the y goes to the top right, and then I have my -1, and that's going to be divided by x squared minus 3. And in order just to kind of clean that up, a y equals to, sorry, I was going to say that although this is the right answer, we can definitely clean this up a little bit here. Let me write this as -3 plus x squared. And then on the top, I can leave the -1 there. And on the bottom, I can factor out a -1. So now I get 3 minus x squared. And then you can see that the minus signs can now cancel off. So your final answer is y equals to 1 over 3 minus x squared. So this answer right here is definitely correct, and for sure this answer over here is also correct. The back of the book has the answer in that format though. Okay, let's move on to the next problem here. So here's my next differential equation. I have y prime equals to all of that, and I know that f of pi over 4 equals to -1. So if I go ahead and just translate this into a point, this is the point pi over 4 comma -1, where this is my x value and this is my y value. Okay, so let's go back to our original problem here, and whenever we're solving differential equations, we want to have the y variables on one side and the x variables on the other side. So I see a y squared, so I can move that to the left-hand side. If I do that, I get y prime divided by y squared equals to cos 2x. So some very basic algebra to start the problem. After that, I will take this y squared and I'll rewrite that in terms of a power. So that's y to the power of -2 times by y prime equals to cos 2x. Okay, so I want to isolate for y somehow, or get my equation right for y, and in order to do that, I need to get rid of this y prime sign. In order to get rid of that y prime, I just take the antiderivative of both sides by integrating. Okay, so if I do that, I can now take the antiderivative. So the antiderivative of y to the power of -2 is going to be y to the power of -1 divided by -1. And that's the same thing as -1 over y, right? So let me just erase this, and I'll replace that with -1 over y. And then the integral sign and the y prime are now gone. And if I go ahead and take the antiderivative of that, there's a 2 here, right? So when I take the antiderivative, that 2 comes in the front as 1/2. And then the antiderivative of cos of anything is going to be sine of the anything. So sine 2x and then plus c. Okay, so there's my antiderivative, and let's go back to the condition that was given to me in the problem. I know that f of pi over 4 equals to -1. So we know that this is our x value and this is our y value. So if I go ahead and highlight the pi over 4 and the x, that's going to come over here. And I know that this -1 represents the y, and that's going to go over there. All right, so let's go ahead and substitute those values in. This is going to be -1 over, now what is y? Well, y is going to be -1 equals to 1/2 sine of bracket 2 times pi over 4 plus c. And the 2 and the 4, they kind of cancel off, so that gives you pi divided by 2, right? So I can erase this, and this is really now just pi divided by 2. Okay, let's keep on solving for this. Our goal is to solve for c here. If I take a look at this, -1 divided by -1 is just going to be +1 equals to 1/2. Okay, so let's take a look at this sine of pi over 2. If I take a look at the graph of sine x, here's a rough sketch of sine x. This is pi, and pi over 2 is right in the middle, and that has a height of 1. So that means this entire expression here in green, that's just equal to a height of 1. So it's going to be 1/2 times 1 plus c. Okay, let me erase that. And if I keep on going along here, this is going to be 1 minus 1/2 equals to c, and c would equal to 1/2. So a little bit of work there to get the value of c. Once you have the value of c, you want to go up a little bit further back to the step where you did the antiderivative. And let me just erase all this here. So I want to continue working with this equation right here, and let me go ahead and just update that and continue solving the problem from here. So if I go ahead and continue to update this, this will be -1 over y equals to 1 over 2 sine 2x, and our value of c was 1/2, so I will put a plus a 1/2 over here. After we do that, the goal is to solve for y. Okay, so maybe the very first thing I'll do is let me take care of this negative sign, because I didn't do that well in the last problem. So if I take care of that negative sign, this will be -1 over y equals to -1/2 sine 2x, and then minus 1/2. Okay, so that's how you can take care of that minus sign. And then this is going to be a bit weird here to kind of explain, but I'm going to take all this and all of that, and those two things are going to switch sides. Okay, so if I switch sides, this is going to be a bit weird, but the y will be in the top right hand corner, and all that stuff that I've highlighted in yellow here, this purple stuff, all of that, that's going to go downstairs on the fraction. So this is going to be -1/2 sine 2x minus 1/2 equals to y there. Let me just try to clean this up a little bit here. This is equal to just y. So got to kind of like do the whole, basically I'm kind of interchanging those two pieces to get a over c equals to b over d. I'm doing some algebra like that, so we can simply interchange the y and everything here on the right hand side there. Okay, although this is correct, we should definitely try to clean this up as best as we can, as best as possible. So I have a -1/2 here and a -1/2. Since there's a negative sign on both terms, it would be best to kind of just multiply everything by -2. So I'm going to multiply that by -2, I'm going to multiply this by -2, and that means I need to multiply the numerator by -2. And that should clean up the problem quite a bit. So if I times the bottom by -2, everything on the bottom by -2, I need to times the top by -2 as well, so that I'm not changing the original problem. Okay, so 1 times -2 is simply going to be -2 all over. And then this part right here, that part right there in green, that just kind of cancels off, and you're just left with sine 2x. And then if I multiply that together, -1/2 times -2 is going to be +1. And that right there is your final answer, and that's kind of cleaned up as best as possible. Okay, let's move on to another differential equation problem. Okay, so for my next problem, I have dy over dx, the derivative on the left-hand side, equals to all of this. And the condition that's given to me is y of 0 equals to 3. So if I go ahead and change that into a coordinate, that's going to be 0, 3. Okay, so this problem is going to take a little bit more work, because I'll be using some u substitution to kind of break this problem down here. If I look at the original problem here, I'm going to circle two things. I'm going to circle the dx, and I'm also going to highlight the y minus 1 all to the power 2. And my first step is I'm going to interchange those two pieces. If I interchange those two pieces, let me just kind of put my work over in the middle here. I get dy over y minus 1 all to the power 2 equals 2. And then on the left hand side, I have this negative e to the 3x, and then I will now multiply that by this piece right here, which is the dx, so multiply that by dx. So I just interchanged the orange and the red pieces, and this is now what I have over here. As you can see, I have all the y's on one side and all the x's on the other side. All right, so let's go ahead and keep on breaking this down here. I have 1 over y minus 1 squared times dy equals 2. And let me just put this all in one color now, negative e to the 3x times dx. Okay. So the goal now is I want to isolate for y, and in order for me to isolate for this y, I need to get rid of this dy. How do I get rid of that dy? I need to integrate both sides. So I need to integrate that side, and I also need to integrate that side. And once we do the integration steps correctly, this integral sign and this dy, they cancel off, and this integral sign and this dx, that will cancel off. Okay, so one of the reasons why this problem is going to take a little bit longer than other problems is that on the left-hand side, this part right here, I will take the antiderivative of that by using u substitution. There are some other formulas out there that will do this really quickly for you, but let me just do this antiderivative by using u substitution over here on the side here in purple. So I'm going to let u equal to the bottom piece, which is just y minus 1. So if I do that, this is going to be 1 over u to the power of 2. And that's going to be the integral sign and dy still. Okay, so I let u equals to y minus 1. And then I take the derivative over here. That's going to be du over dy. And that's simply going to be 1. If I go ahead and interchange those two pieces, this is going to be du equals to dy. And as you can see, this dy matches up with that dy, so that blue dy equals to basically this du. So I can just replace that over there. Okay, so let me just erase this, and that's going to be du. And we're pretty much ready to take the antiderivative of this now, and if I keep on taking the antiderivative of this, this will be u to the power of negative 2 times du, and then now the antiderivative of that is going to be u to the power of minus 1 divided by minus 1, and this, we've seen this a few times already in some of the homework questions. This is going to be negative 1 over u, and remember u equals to y minus 1, so the final antiderivative is going to be negative 1 over y minus 1. That's how you find the antiderivative of the left-hand side. Okay, so let's go back and let's go ahead and update our problem now. Let me erase all this, erase all that. Okay, so after doing a little bit of work here, the antiderivative of this is going to be negative 1 over y minus 1. And that's going to be equal to everything on the left-hand side. Now the right-hand side is a little bit easier to find the antiderivative of. If I want to find the antiderivative of this expression right here, there's a 3x there. So if you're taking the antiderivative of e to the power of like 3x or kx, you need to have the 1 over 3 in front. And then the minus sign kind of carries along. And then you have e to the 3x. And then you need to have a plus c as well. So the right-hand side was a little bit easier to find the antiderivative. But the left-hand side, that one did take a little bit more time. Okay, so now that we have taken the antiderivative with the plus c, let's go back to the original problem. And the original problem tells us that y of 0 equals to 3. And this is your x value. And that's your y value. So just like the previous problems here, anytime we see an x, we're going to replace that with 0. And anytime we see a y, I'm going to replace that with 3. So let's go ahead and substitute those values in. So now I have negative 1 over 3 minus 1 equals to negative 1 over 3 e to the power of 3 times 0 plus c. Okay, and on the left-hand side, I have negative 1 over 2. And on the right hand side, I know this part right here, that will be equal to e to the power 0, which is 1. So 1 times negative 1/3 is negative 1 over 3 plus c. And if I keep on solving for this, I get c equals to negative 1/2 plus 1/3. And c would now equal to negative 1 over 6. So this problem did take a little bit more time in terms of finding the antiderivative and finding the value c. But let's keep on going forward here, and let's go back to this step of the problem. Let me erase all this now. So just like all the other problems here, let me kind of box this part of the problem here because we did find c. And let me just update this part of the problem here. So this is going to be negative 1 over y minus 1 equals to negative 1 over 3 e to the 3x. And then our value of c was negative 1 over 6, so negative 1 over 6. Okay, now let's go ahead and our goal now is to isolate for this y here. And let's get rid of this minus sign here. So if I multiply everything by this minus sign, these minus signs will pretty much cancel out, and I get 1 over y minus 1 equals to 1 over 3 e to the 3x plus 1 over 6. Okay, now this is very similar to the other problem here. There's a few ways you can really do this, but I'll try to do this a different way. If you have a 1 here, and if you want to get rid of that, you can just kind of flip both of these. So this is the same thing as y minus 1 over 1. You can flip it, and if you flip one side, it just means you need to flip the other side. So maybe that might be a better way of explaining how to isolate for y, which is, I mean, this step right here is similar to the previous problem, but I'm just using this flipping method because it might make the problem a little bit easier. Okay, so and if I take a look at this part right here, y minus 1 divided by 1 is just y minus 1. Okay. After that, let's take this minus 1 to the other side, and that's going to equal to y equals to 1 over 3 e to the 3x plus 1 over 6 plus 1. And after that, let's get rid of these fractions here. So the least common multiple there is going to be 6. So I can multiply this by 6, I can multiply that by 6, and then I can multiply that by 6. So I can completely change that fraction to get rid of the, to clean up the denominator there. So 1 times 6 is going to be 6. This 6 and that 1/3 is going to be 2. So 6 times a third is going to be 2 e to the 3x plus 6 times 1 over 6 is going to be 1. So 2 e to the 3x plus 1, and then this 1 over here just tags along. So that right there is my final answer for that problem. Okay, let's go to the final problem in this homework video guide, and that's question number 8 here. So here is my differential equation, and I'm highlighting my derivative symbol right there, and my condition is f of 1 equals to 0. Okay, so this pretty much means that the x value is 1 and the y value is going to be 0. So 1 comma 0. Okay, so let's go ahead and let's see if we can isolate this problem here. There's a little bit of algebra we have to do here. So I see this negative 4. Let me bring that to the other side. If I do that, I get x times dy over dx equals to y squared plus 4. That's kind of like step number 1. And then what I see here is, okay, so here's my y squared plus 4, and here is my dx. Let's go ahead and interchange these two pieces right here. If I do that, I get x times dy over x squared plus 4, or sorry, not x squared plus 4. Let me put that in orange here, y squared plus 4, and that's going to equal to dx. All right, so there's a little algebra step right there, and then finally I'm going to take this x here and I'm going to move that down there. Okay, so if I do that, I get dy divided by y squared Actually, let me just rewrite this a different way. I'll write this as 1 over y squared plus 4 times dy equals to dx over x. And then let me just kind of rearrange this to look like this now, 1 over x times dx. One of the reasons why I'm just kind of rewriting the terms like that is because it's going to be easier for me to do the next step, which is finding the antiderivative. So eventually I want to solve for y, so that means I need to get rid of this dy. In order to get rid of the dy, I need to integrate both sides. If you integrate one side, you have to integrate the other side. Okay. Now, if I continue on with this problem here, let me just kind of rewrite the problem in a different way here. This is going to be y squared. And this 4 right here, it's probably best to write that as 2 to the power of 2 dy equals to the integral of 1 over x dx. Okay, so if you look at your formula sheet, you can definitely find the antiderivative of that. That's one of the inverse tan properties. And this 2 here means you'll have a 1 over 2 in front. So 1/2 times inverse tan of this guy, which is y, and then you divide it by this 2, which is y divided by 2. So you can definitely find that on your formula sheet. I would recommend that. That's probably the fastest way to do this. You don't use substitution. You just have to recognize that the antiderivative of 1 over y squared plus 2 squared is one of the inverse tan options. Then on the right hand side, this is actually not too bad. The antiderivative of 1 over x is going to be ln x. So ln absolute value of x and then plus c. All right, now we need to find plus c now, and we have to use our initial condition, which is f of 1 equals to 0. As mentioned in most of the problems here, this is your x value, which is 1, and your y value is 0. And then if I start clearing some space here, x value of 1, this is going to be that guy right there, and y is going to be 0, so that's going to replace the y over there. All right, so let's go ahead and just substitute those values in now. This is going to be 1/2 tan inverse 1 of 0 over 2 equals to ln of the absolute value of 1 plus c. And we kind of luck out here because ln of 1 is going to be 0, 0 plus c. And over here, inverse of tan, basically 0 divided by 2 is going to be 0. And if you think about a tan function here, it goes to the origin 0, 0. And if you take the inverse and switch x and y, you still get 0. So this whole thing in blue is simply going to be 0. So 1/2 times by 0 is going to be 0. So that means my value of c is equal to 0. Okay, let's go back and update our formula, and after that we can probably just finish up this question now. Okay, so let me just erase all this and create a little bit more space here. I'm going to erase all that, Okay, so we know that this value here is going to be 0. So let me just kind of erase the plus c and just leave it as 0. I mean, if you just want to write 0, you can as well. But now let's go ahead and solve for my y now. This is the goal. Okay, step number 1, I need to get rid of this 2 on the bottom. That means I times the right hand side by 2. So 2 times ln of absolute value of x. Once that's done, I can get rid of this 1/2 in front, and I have tan inverse of y divided by 2. Okay, after that, how do I get rid of this inverse tan? Well, you need to tan both sides. Okay, and once you do that, that eliminates that, and now you have y over 2 equals to tan bracket 2 times ln x. And then we're almost done now. The last step is, how do I get rid of that 2 there? Well, you just multiply both sides by 2. So that's going to be a 2 there, and then times by tan, a bracket 2 times absolute value of ln x. And that right there is your final answer for that problem. And that concludes this homework video guide.